Hey everyone, my name is Dan Eaton. I'm an applications engineer with NI. Today I'm going to show you how to build and deploy real-time sequences in NI VeriStand. So before we even get into real-time sequences and how to deploy them, we should really know what they are and when to use them. So we're going to start with understanding our setup. So here, when you're working with VeriStand, often you have a host. There's usually Windows where you do configuration and visualization, and then you have a real-time target, a embedded controller with its own CPU running the NI Linux real-time operating system. And so with that as our setup, you can, when you're automating, choose, do you want to automate on Windows, or do you want to automate on the real-time controller? And so the real deciding factor for that is, do you need precision timing or do you need determinism or both? And anytime that you're not really caring about timing, critical timing, or determinism, Windows is actually the best option. And there we have many ways of automating VeriStand. You have TestStand, you have lots of Python options. We have LabVIEW code as well to do that, or you can automate directly within VeriStand. And then on the real-time target, if you decide that timing, precision timing, and determinism matter for what you are trying to automate, then it needs to live in the real-time operating system on the real-time CPU. And for that, you have to use a real-time sequence, which is the whole context today of how to build a real-time sequence. So, but step one is know your setup, know what you need to run where. So for today, what we are going to walk through is using the shipping example for VeriStand, the engine demo. We're going to use that just so that anybody else can follow along. And we're going to build a real-time sequence because what we want to build is a ramping function for our motor controller. So in here, we have a simulated motor in this engine demo. We're going to write a real-time sequence where, because we're ramping, we want it to be deterministic. We care about timing. So we're going to use a real-time sequence. So I'm going to go ahead and open up this example. You can find it in your public documents, National Instruments, NI VeriStand year examples, and then stimulus profile folder. So we'll go ahead and open up this example. I am going to deploy it and just let it start running in the background. So we're going to open up the screen so that we can talk through those pieces, and then we're going to deploy this. Right, so that's now pushing the configuration to a real-time controller. And then what we've got while that's happening is we're going to say there's a start the motor. It's going to idle at a certain speed. That's kind of designed into the motor model. And then we're going to be able to change set points and see how well the motor model performs using this desired RPM. So when we write this ramp function, what we're really going to be doing is changing the desired RPM in a deterministic way so that we actually can do the ramping. Okay, so there we've deployed. To get to writing a real-time sequence, you first go to Tools Launcher and then to Stimulus Profile Editor. So we're going to go ahead and open that up. There we go. All right, so we've got two different things you can create in the Stimulus Profile Editor. One is Stimulus Profiles. That's really for from the host calling a real-time sequence running on the target, on the real-time target. We're not going to use that today. We're just going to worry about the real-time sequence itself. So we click real-time sequence. I like to save early and often. So we're going to call this my sequence. All right, now if you haven't seen this before, this is the sequence editor. You've got all of your primitive functions here. These are like the base functions that you use to build everything. So these are variables that you can drop down, just grab and drop. These are expressions. You've got for loops, while loops. You've got multitasking, which lets you do multiple threads that run truly in parallel. So if you need to be, for example, running a ramp, but also checking a safety limit at the same time, but in parallel, you could do that with the multitask, as well as your conditional functions like if, then, and switch. Down here is the area where you can call other real-time sequences. So here, right, we've got our my sequence. You can call this function from other functions. You can call already made functions. So here we have a list of already made real-time sequences that you can go in and call. So for example, here is a ramp that we've already got. But this ramp is just a start point, end point, and I want to build a different type of ramp. But you can grab this, drag it, and even double click it and see what it's doing. Actually, I'll double click it here. So here you can see it's a sequence, right? This is the shipping ramp sequence. All right, next thing to know, over here, we've got our variable pane. So you've got parameters. These are what define your sequence's function. It's prototype, so to speak. So you can have input and output parameters. Then you've got local variables that are literally local to this sequence file. They cannot be accessed outside of that file. And then you have channel references. And so what channel references are when you want to just go direct to a VeriStand channel and read or write it. Down here, this is where you set what system definition, what configuration you're using. So if you want to load these channel references, you pick your project down here, and it will load all the available channels. If you want to look at a different, or you want to write a sequence offline, for example, you can point it at any system definition. It will load the channels there. Last thing is that there's this context help section here where you can hover over anything and it will give you information. And then finally, we'll be doing a fair amount of work here in this property browser section. This is really where you modify all of the functions and expressions to do the real work. All right, so we're going to start with building our ramp function here. What I want this ramp function to be is actually, instead of a start point, end point, and duration, like the shipping ramp here, I actually just want an endpoint and a ramp rate. So the idea is that I can just say, wherever you are, wherever you last left off, I want you to ramp at this controlled speed up until you hit a certain point. That is what I want to do. So based on that, we're going to need some variables. So you can see there I'm right-clicking to insert a variable. I want to name the first one. You can see it loads over here in the property browser. I want to call the first one ramp rate. And that's in really units per second. And then we're going to make an end value. Now you can already see here it says ref. I don't want to do ref. I want to do by value. What that essentially does is whatever value you pass into the function when you call it, it caches that value and just uses it the rest of the function execution. But for certain things like ramp out, we want that to be updated all the time. So anybody linked to ramp out would get updated every time ramp out is set. So here we're going to link this by default to an alias. You should always use aliases for writing sequences because it allows for a little bit of abstraction. But we're going to point it to the desired RPM for ramp out. Okay, so I think now we've got our core functions, our core parameters, right? We've got our ramp rate, how fast we want to go, where we want to end up. And we've got a way to set our output, which is in this case, the desired RPM. So now we can do some logic things. All right, so we're going to grab an expression, drag it over. You see how I can just drag over all these functions to use them. And then I immediately come over and enter in values here. All right, so I think what I want to do is, I know where I start because that's what ramp out is. Ramp out is where I'm actually starting, and I know what I want the end value to be. So what I want to do is I actually want to find out how much do I have to change. Then I also want to find out how long is it going to take me to get there based on ramp rate. So those are the two things I want to figure out to start. I'm going to create a local variable that is delta ramp. This will give me the change. I'm going to actually drag that over. You can see it can drag. Delta ramp is going to be end value. See the IntelliSense, and you just hit tab. Minus ramp out, because that's where I am right now. And then I like to put everything in parentheses just because it makes it easier for my brain. All right. Now I've calculated how much do we have to change. I'm gonna now want to create a variable that's just the duration, like how long is it going to take? So duration, seconds. So then this expression that I dropped earlier, I can say duration IntelliSense is equal to delta ramp. By ramp rate. Here we go. And then parentheses. All right. Yeah, that makes sense, right? Because we've got the amount we have to change over same units, the ramp rate units by seconds, and that'll get us to duration. So that tells us how much we have to change and how long it will take to get there. All right, so now if you're familiar with VeriStand, it has something called a primary control loop, and that is the thing that is kind of stepping models, stepping I/O. It happens at a user configurable rate. So the user can say, I want to run at 1 kilohertz or 100 hertz. And so it will then step at a period relating to that rate. So to make this function generic and work with any primary control loop rate, we're going to go to channel references and say insert channel and pick delta t. So delta t tells us essentially what the period is set by the user. Even if I hover on that section there, you can see in the context help, it says the period in seconds of the primary control loop. So that gives me essentially the loop rate or the period of the loop. And the reason I want that is I want to get to knowing how many iterations of a for loop do I need to execute. So we've got duration. We now know how many steps are in duration, or we're going to calculate, I should say, how many steps are going to be in duration. So I'm going to grab a assignment and say, I want to calculate PCL ticks. And that is going to be equivalent to duration divided by delta t. All right, now on purpose, I have put in a little error here. So like this is not a defined variable yet. So if I come and hit compile, that's where it kind of does the sanity check on your sequence. It won't tell you if you have bad logic, but it will at least tell you if you have undeclared variables or functions or things of that nature. So you can see it says, hey, you haven't declared that thing, so I can come over here and insert a new variable that I'm actually going to make an I64 because it's the number of iterations, so that should be an integer. I call that PCL ticks. Come back, hit compile. Everything's happy. I'm going to save it. Now, another little fun feature of real-time sequences. We just said that PCL ticks needs to be an integer, and we're doing division. That doesn't always work out. So there are functions that you can see that when I start typing, right, there's all these functions that are built into the real-time sequence editor. So I'm going to pick ceiling so that we have some rounding happening. So I'll make sure we get an integer value out for the number of ticks. All right, so we know how much we have to change. We know how long that has to take. We know how many ticks of the primary control loop rate that is. And then I think the last thing we need to do is figure out what is the real ramp rate, right? So we know what the user gave us in seconds, but let's figure out what it is in terms of ticks. So we're gonna say create a new variable that's local. That is ramp rate per ticks, per tick. All right, and go drop that over there and then type out that it's the ramp rate multiplied by delta t. All right, so this will be our period. So for example, a little sanity check, if somebody says the ramp rate is 1,000 RPM and we're running at a kilohertz, that means delta t would be 1 millisecond, which is 0.001 seconds, and that would make the ramp rate per tick 1, which is exactly right. Okay, so then we're going to grab now, we've done our setup logic initialization. Take the for loop, drop that in. Here you can see iteration count. So we're going to set this to PCL ticks. And then we've got our actual ramp we got there. So here we're going to say ramp out is equal to ramp out, but plus the ramp rate per tick. So I'm going to hit compile. Everything's at least logical. I can get rid of this. That was from our example showing off the ramp earlier. Okay. So let's go ahead and try to run this. Now I do know I've left in an issue so we can show updating this, but I think this will let us ramp. So we can come back to our deployed configuration. Here we can start the motor. It's going to ramp up to the idle speed. We can set a desired RPM even, like 1,000, and we'll ramp to that. And then we can go ahead and call it. Now, again, you can call these real-time sequences from lots of things, teststand, LabVIEW, Python, but we're actually just going to call it directly within the tool. So we're going to call it using a real-time sequence control, where we then navigate to that thing on disk. So let me do that. All right, we got there. Okay, so now we've selected it on disk. We're saying it's going to go at controller. And then we're going to go configure parameters. So this is where you can actually set the prototype values. So we want the ramp rate, we'll say 1,000 just for an easy sanity check. We want the end value to be 5,000. Say OK. All right, so we've got the engine on, we're at 1,000, going to 5,000, should take roughly 5 seconds. We'll hit run. Sure enough, you can see it's ramping in about 5 seconds. The model is getting there. It stopped at 5,000. Perfect. Yeah, even in there, you can say, oh, sorry, it should take 4 seconds. We're starting at 1,000. So the delta is 4,000 RPM. And there you can see it took about 4 seconds. Okay, now the thing I know I purposely left out. So what about if we go the other way? So if I now change the set point to be 6,000, the starting point, right? Because the whole point of this function is you start where you are and you ramp down at a rate. So according to my configuration here, we should be ramping down to 5,000. I go ahead and hit run. It should be happening in about a second. You can see it did nothing, right? The reason for that is we're already above 5,000. So while this is still running without changing anything here, we can go back to our sequence editor. And then we can say, actually, I need to figure out which direction to ramp. So I'm going to create a if then. So I'm going to go ahead and grab this, drag it in, and then say if, here my test expression, if delta ramp, the change that we have to make is greater than 0. And then we are going to do what we were already doing. But if it is negative, we're going to copy, and we are just simply going to make that a negative number. And then the other thing I want to do is duration. We're going to make that absolute because we should never have a negative duration. All right, so we've gone in and we've updated. We've made it so it has direction. We've saved it. So all we have to do is come back here and try again. So now we're just going to run it. And it changed, right? Thumbs down. Well, hopefully that teaches you how to write real-time sequences, deploy them to a real-time target using our Linux real-time operating system, all in VeriStand. If you want more information, please visit our website, ni.com/VeriStand, where you can download VeriStand, get documentation, access support, and even connect to the VeriStand community. Thank you for your time.